this lesson, we're going to talk about completing the square. So if I'm solving a quadratic equation, normally when I see that, I'm just going to immediately start factoring. But the problem is that sometimes a quadratic equation can't be factored. So we need other ways to solve the equation. And that's where completing the square can come in. That's one way we can solve when we can't factor our quadratic. So if you take a look at number 1, I have a 25 equals, and then I have my quadratic equation. Now, if you look at that quadratic, you're going to realize that it is a perfect square trinomial, meaning that when I factor it, I'm going to get two of the exact same binomial. Now, we don't always recognize that from the get-go. So let's say that you don't recognize that, and you just begin factoring it. That's fine. You're going to see it in a minute. So I've got a plus at the back, so I look up front. That gives me two plus signs. I have x and I have x. And two numbers that multiply to make that 49 that will add to make 14 are 7 and 7. Now, if I knew that that was a perfect square trinomial, that would have been less work for me. I would have just known immediately it was going to be x plus 7 squared. All right. So now I'm going to solve this. I see that I no longer have like an x squared. I just have that x right there. So I'm going to go ahead and get rid of this square. And when I do that, I'm going to have a positive answer and a negative answer. So my square and my square root cancel. I'm going to kind of flip sides here. So I have x plus 7 is equal to plus or minus. Well, I know that the square root of 25 is 5. Then I need to subtract the 7. Now, when I have a plus and minus on this other side where I'm moving the 7, I would like for you to put that in front of the plus and minus sign. That way you don't forget that it's negative 7 plus 5 and negative 7 minus 5. So we have two answers. Now, negative 7 and 5, those two numbers are like terms. I can combine them into one number. So I'm going to do that. Negative 7 plus 5 gives me negative 2. And negative 7 minus 5 gives me negative 12. Now remember, with quadratic equations, you always have two answers, and that's because your degree is 2. So I do have my two answers. So number 2 is exactly the same. I have another perfect square trinomial. So instead of doing this by factoring into 2, I'm going to go ahead and just say that I have two of the same thing. So I have a plus in the back, which means both of those would have had a minus. I'm going to take the square root of that x squared. That goes in the front here, and the square root of 64 is 8, and that is equal to 9. Again, you could have just factored like we did on number 1 and then realized you had two of the same thing. That's fine. So now I'm going to solve for x by taking the square root. So I get two answers, a positive and a negative. So x minus 8 is equal to plus or minus the square root of 9 is 3. And then I'm going to add that 8 to the other side. And when I do that, I'm going to put that in front of my plus and minus sign. And then I have two answers. I have 8 plus 3, and I have 8 minus 3. Now, I know that 8 and 3 can be combined into one number. So 8 plus 3 gives me 11, and 8 minus 3 gives me 5, and there are my two answers. So we've kind of started off with two equations that could have been factored, really. If I moved, say on number 1, if I subtracted the 25, I still could have factored that, and I would have ended up with negative 2 and negative 12. But I wanted to kind of show you that when you have a perfect square trinomial, that actually makes things easier on you. And when you are doing completing the square, you're going to have to come up with a perfect square trinomial. So we are going to talk about how to do that. So not every quadratic expression is a perfect square trinomial. So completing the square is the process of finding the constant that you can add in to create a perfect square trinomial. So in order to do this, you're going to want the coefficient of your x squared to be 1, and you want the x squared and the x term to be on one side together, and you want your constant to be on the other. So I do see that my x squared has a coefficient of 1. I can see that my x squared and my negative 6x, they are on the same side of the equal sign together, but my constant term needs to be on the opposite side. So I am going to move that 11 by adding it to the other side. All right, now I'm going to create a perfect square trinomial. So what I'm going to do is I'm going to add a number to this side that's going to make a perfect square trinomial. And if I do that to the left side, I also have to add that same number to the right-hand side. Now here is where we come up with that number that goes in the blanks. We're going to take the number that's in front of the x, and we are going to divide it by 2. So I'm going to take 6, and I'm going to divide it by 2. That gives me 3. And then I'm going to take that number, and I'm going to square it. 3 squared is 9. So I'm going to add 9 in this blank and add 9 in this blank. The whole point of doing that is so that we get a perfect square trinomial. So if I factor this, it's going to be 2 of the same. Plus in the back, 2 of what's in front, x and x, and what multiplies to make 9 that adds to make 6 is 3 and 3. Instead of writing this out, I can immediately do the same thing squared. I already know that both parentheses would have a minus sign. The square root of the x squared is x, and the square root of the 9 at the back is 3. Also, it's going to be whatever you squared. Okay, so 3 goes in the blank, equals, and then this side, I'm going to put these two numbers together. 11 plus 9 gives me 20. Okay, so it just asked me to write that as a perfect square, so I will stop right there. Number Okay, on number 5, again, this is going to be one that can't be factored, okay? Like there's nothing that multiplies to make 5 that will add to make 8. So we're going to have to come up with a different way to do this. And keep in mind that what we're doing right now is just a part of the whole process. We're just kind of doing little pieces at a time. So I'm going to look up here in the front, and I have a 1 in front of my x squared. That's what I want. My x squared and my 8x are on the same side of the equal sign, but my constant needs to move to the other side. So now I have x squared plus 8x equals negative 5. Now I want to make a perfect square trinomial on this left-hand side, so I'm going to figure out a number that I can add to this that makes it factor into 2 of the same. Now if I do that on the left, I have to add that same number on the right. So I'm going to take that 8 that's in front of my x, and I'm going to divide it by 2. 8 divided by 2 is 4. Then I'm going to take that 4 and square it. That gives me 16. So I'm going to add 16 to both sides. Now the whole point of completing this square is so that I get a perfect square trinomial. So I immediately know that when I factor the x squared plus 8x plus 16, I'm going to get 2 of the same. So I know that if I got 2 of the same, the sign is going to be 2 of whatever's in the front, so there will be a plus sign. The square root of x squared is x, and the square root of that 16 that I put on here is 4. And again, it's going to be whatever number you squared to get that number. equals, and then I put together my -5 and my 16, which makes 11, and so I have written this as a perfect square. All right, number 5 is exactly the same. I have a 1 in front of my x squared. My x squared and my -18x are on the same side. However, I need to move that constant to the other side. Now, I really like to write my x squared on the left, so I'm going to put the x squared minus 18x on the left and the -64 on the right. Now I'm going to make a perfect square trinomial with all of this on the left-hand side by adding a number in. And I do the same thing on the right. I'm going to have to add that same number because what we do to one side, we do to the other side. So to get that number, I'm going to take the number in front of my x. And by the way, the sign doesn't matter because you end up squaring it. So 18, and I'm going to divide it by 2, which gives me 9. And then I'm going to square that number. 9 squared is 81. Now, the whole point of completing this square is so that I get a perfect square trinomial. So I know that when I factor, I'm going to get 2 of the exact same binomial. I look at the back, remember, there should be a plus there. 2 of what's up front, so minus. Square root of x squared is x, and the square root of 81 is 9, equals, put together your -64 and your 81, that gives you 17. Okay, and on this last one, don't be afraid because of fractions. It's fine. All right? So I do the same thing. I notice there is a 1 in front of my x squared. My x squared and my term with the x are on the same side, but I need to move the constant to the other side. So I have x squared minus 3/2 x. And then I know I'm going to be adding a number here, so I'm going to go ahead and put the blank. And then we have 70 over 8 plus, and then I'm going to have to add that same number over here. So I have 3/2, and I'm going to take that and divide it by 2. That gives me 3/4. Then I take 3/4 and I square it. Now I could plug that in the calculator, or you could just realize that you square the top and the bottom, so that gives you 9 over 16. So that is what I'm going to put into the blanks, 9 over 16. Now, the whole point of doing that was so that I got a perfect square trinomial right here. So I know that I get 2 of the exact same thing when I factor it. Both signs would have been a minus sign. Square root of x squared is x, and the square root of 9 over 16 is 3 over 4, and remember, it could just be whatever you squared if you need to think of it that way, equals, and then I have to put together my 70 over 8 and my 9 over 16. That gives me 149 over 16. If you need to use your calculator, by all means do that. All right, now we're going to solve by completing this square. So we're going to take what we just did, and we're going to combine that with what we did on numbers 1 and 2 and do the solving part. So in the end, we should actually have an answer of x equals something. So I see that I have an x squared that has a coefficient of 1. I have my x squared and my x on the same side, but that constant needs to be on the other side. So I have x squared minus 2x. I already know I'm going to add a number here, so I'm going to put the blank there, equals, and then I have my -3 on the other side, and I'm also going to have to add a number there. So I take that number in front of my x, which is 2, and I'm going to divide it by 2. That gives me 1, and then I square that number. 1 squared is 1. That's what goes to complete our square. The whole point of completing the square is so that we get a perfect square trinomial. So I know immediately when I factor this side, I get 2 of the exact same thing. Both have a minus sign because that's what's up in the front. Square root of x squared is x, and the square root of 1 is 1. That is equal to the -3 plus 1, which is -2. All right. Now I'm going to continue on, and I'm actually going to solve for x. So I take the square root. I'm going to have positive answer and a negative answer. So x minus 1 is equal to plus or minus. Now 2 is a prime number, so I know that I can't do anything with that. But remember, this is like the square root of 2 times the square root of negative 1. And when I have the square root of negative 1, I have to replace that with an I, and I want my root to be last, so this would be I square roots of 2. And now that I've simplified that right-hand side, I'm going to add 1. And when you have a plus or minus over there, you're going to put that in front of that. So this would be 1 plus or minus I square roots of 2. Now that is two answers. One of the answers is 1 plus I square root of 2. And the other is 1 minus I square root of 2. That is two separate answers. Now they're both imaginary. And we've gone over complex numbers, imaginary numbers, but when you graph these, you should see your solutions as your x-intercepts, but we have imaginary solutions. So I want to graph this so you can see what complex solutions look like on a graph. So let's grab our calculator. And let's graph what we have. So go to your y equals. You're going to put that equation in. X squared minus 2x plus 3. Now we already know that both of our solutions are imaginary. And we know that normally when we get solutions, we'll see them cross the x-axis because the solutions are our x-intercepts. But if you look at this one graphed, it never crosses the x-axis. That's because our solutions are imaginary. We have a complex solution. And so if I have i's in my answers, both of my zeros are going to be imaginary and they won't actually cross the x-axis. So take a look at number 8. All right, I'm going to check to make sure there's a 1 in front of x squared. There is. Both x's are on the same side, and I'm going to subtract the 8 and put it on the other side. Now I know that I'm going to add a number to this side, which means on the other side I also have to add that same number. So I look at the number in front of x, I'm going to divide that by 2, that gives me 2, and I square that number. 2 squared is 4. So 4 is the number that is going to complete the square. And when I complete the square, I am making a perfect square trinomial. So when I factor this, I get 2 of the exact same thing. All right, I will have a plus in the middle. The square root of x squared is x, and the square root of 4 is 2. On the other side, I have negative 8 plus 4, that's negative 4. Now I'm going to solve. So I square root to get rid of the square. Don't forget your positive and negative answer. X plus 2 is equal to plus or minus 2i, because the square root of 4 is 2 and the square root of the negative 1 is I. Then you're going to subtract 2 and make sure that you put that in front of your plus and minus. So again, if I graphed this, those answers, I could not see them cross the x-axis. I won't have any actual x-intercepts. Okay, so now again, I'm going to make sure there's a 1 in front of x squared. There is. My x's are on the same side. My constant needs to be on the other side, so I'm going to subtract the 60. So I have x squared plus 8x plus some number equals negative 60 plus some number. All right, so to get that number that completes the square, we're going to take the number in front of x, divide it by 2. That gives us 4. Then we square that number. That gives us 16. So 16 is the number that completes the square. The whole point of completing the square is so that I make a perfect square trinomial. So 2 of the exact same thing when I factor this. We have a plus up front, so there will be a plus in our binomial. The square root of x squared is x, and the square root of 16 is 4. That is equal to negative 60 plus 16, which gives us negative 44. Now I am ready to solve, so I square root. That gives me a positive and a negative answer. So x plus 4 is equal to plus or minus. Now 44 is not a prime number. It is also not the product of prime numbers. So I'm going to do a factor tree for 44. So I have 2 and 22. 22 is 2 and 11. So I have 2 squared and 11. So 2 squared is a perfect square. 11 is a prime number. So I'm going to square root those. So that gives me 2 square roots of 11. Now, I also have that negative underneath, so I know I get an I as well. So that would give me 2I square roots of 11. Now I just subtract the 4. So x is equal to negative 4 plus or minus 2I square roots of 11. So again, we have 2 imaginary answers. All right, on number 10, I do have a 1 in front of my x squared. My x squared and my x are on the same side, and my constant is already on the other side. So immediately, I can go ahead and complete the square by adding a number to the left side. And because I'm doing that, I have to add that same number to the right. So I'm going to take that number in front of my x and divide by 2. 14 divided by 2 is 7. Squared is 49. So that's going to go in the blanks. The whole point of completing the square is so that I get a perfect square trinomial, and when I factor it, I will have 2 of the exact same thing. So I have a plus up front. That's what I'll have in my binomials. The square root of x squared is x, and the square root of 49 is 7. And then I need to combine my 51 and my 49, and that's going to give me 100. I'm going to square root. Don't forget my plus and minus. So we have x plus 7 is equal to plus or minus. The square root of 100 is 10. It's a perfect square. Now I can subtract the 7. So x is equal to negative 7 plus or minus 10. Now negative 7 and 10 are numbers that I can combine to make one number. So I have x equals negative 7 plus 10. And I have x equals negative 7 minus 10. So x is equal to 3. And x is equal to negative 17. Now, when you get 2 integers as answers, that means that you could have subtracted that 51 in the beginning, and you could have factored that into negative 3 and positive 17 and then solved. But we're practicing completing the square. As you can see, even when you think you have to complete the square, sometimes you may not. So multiple ways to get to the same exact answer. Now, so far, everything that we've done has had a 1 in front of the x squared, but there are times when we really need to take care of a number that's in front. So number 11 and number 12 both have a number in front of our x squared. You can't have a number other than 1 as your coefficient up there. So if you have a number, you need to go through and divide everything by that number, even if it doesn't divide evenly. So since I have a negative 2 in front of x squared, I need to go through and divide everything by negative 2. In order for this to work, you have to have that number be a 1 up there. So that gives me x squared plus 6x minus 9 equals 0. Now, I have a 1 in front of x squared. My x's are on the same side, but I need to move my constant over. So we have x squared plus 6x, and then I know I'm going to be adding a number to complete the square. Same thing here. So we have x squared plus 6x plus a number, and we're going to make that a perfect square trinomial. So we take the number in front of the x and divide it by 2. That gives us 3. Then we'll square that. 3 squared is 9. The whole point of completing the square was so that I got that perfect square trinomial. So I know I have the same thing squared. Since there's a plus up front, I will have a plus. The square root of x squared is x, and the square root of 9 is 3, and 9 plus 9 over here is 18, and then I go ahead and solve. So take the square root. Don't forget your positive and negative answer. So we have x plus 3 is equal to plus or minus. I need to reduce the square root of 18. So I have 2 and 9, and 9 is 3 and 3. So I have 3 squared and 2. If I square root both, that gives me 3 square roots of 2. No I on this one because I didn't square root a negative. Then I'm going to subtract 3. So x is equal to negative 3 plus or minus 3 square roots of 2. And since I cannot combine those two numbers together because they're not like roots, then that will be my answer. Now, since that's not imaginary, if I were to graph the negative 2x squared minus 12x plus 18, I would see that it crosses the x-axis at two different locations, one at negative 3 plus 3 square roots of 2 and one at negative 3 minus 3 square roots of 2. So when there's that number in front, you really just have that one extra step. So since I have a negative 3 in front of my x squared, I'm going to go through and divide everything by negative 3. That gives me x squared in the front, positive 8x, and then negative 19 does not divide by negative 3. So I'm going to go ahead and I'll just simplify it, which it doesn't reduce either. But it does make a positive 19 over 3 and then equals 0. Now we'll just set everything up. So x squared and 8x stay on the same side. We're going to add a number to make a perfect square. And then I'm going to subtract the 19 over 3. And I'm going to add a number over here as well. I take the number in front of x and divide it by 2. That gives me 4. And then I'm going to square that, which gives me 16. So that's my number that goes in the blank. And then the whole point of doing that was so that I could factor it into two of the same. Plus square root of x squared is x, and the square root of 16 is 4. And then I need to add together the negative 19 over 3 and the 16. That's going to give me 29 over 3. Now I have to square root. So I have x plus 4 is equal to plus or minus. Now 29 is a prime number and 3 is a prime number, and it does not reduce, so we're just going to leave it alone. Later we'll learn how to rationalize our denominator, but for now we're going to leave it that way. Now I will subtract 4. So x is equal to negative 4 plus or minus the square root of 29. Again, we got two real answers, okay? So if we were to graph that, it would cross the x-axis at two separate locations. All right, so now we're going to talk about how to write the equation in vertex form, and we're going to use a graphing utility to graph that, and then we're going to talk about the minimum or maximum of the value, minimum or maximum value of the graph. So number 13, we are in standard form. I know that we're in standard form because it's ax squared plus bx plus c. So first things first, in order to write this in vertex form, we need to remember what that is. So y equals a times x minus h squared plus k. So I want to write it like this. So the first thing that I'm going to do is I'm going to move the constant to the other side. So I'm going to subtract 1. So I have y minus 1 is equal to negative 2x squared plus 10x. Now what I want to do is I want to factor out a common factor, but I don't want to take the x out. And actually what I'm really trying to do is I'm trying to get a 1 in front of my x squared. I want the x to not have a number with it. So I guess technically it's not the common factor, it's just it's working out to be a common factor on number 13. So whatever number is in front of your x squared, that's the number you're going to factor out of this. So since I have a negative 2 in front of my x squared, I'm going to factor out a negative 2. That is going to leave me with negative 2x squared divided by negative 2 being x squared. And 10x divided by negative 2 is negative 5x. Okay, now I need to make a perfect square because that's what goes right here. So as you can see, I already have the a value in front, but I need to make this into a perfect square. So in order to do that, I'm going to have to do the same thing that we've been doing. So we are going to take and add a number to make this a perfect square. Now, if I add a number on this side, I also have to add a number on the other side. So I'm just going to say, I'm going to add a number over here as well. Now, this is where some people will mess up, okay, is after you get your number, so make sure you're paying attention. So I'm going to take that 5 that's in front of my x, I'm going to divide it by 2. Now 5 doesn't divide by 2, so now I'm just going to take that and square it. That gives me 25 over 4. That's the number that I am going to put in this blank. Now, since I have 25 over 4, I really hate having the fractions in this problem, but I'm going to leave it there for now. I can't add 25 over 4 over here because this is 25 over 4, but it's actually 25 over 4 times negative 2. Because if I were to distribute negative 2, I would have to distribute it to that number, and that's what would be actually being added over here. So 25 over 4 as a decimal is 6.25. So we're going to take 6.25 times negative 2, and that's going to give us a negative 12.5. So now on this side, if I take negative 12.5 and I combine it with its like term of negative 1, I get negative 13.5. And on this side, I know that because I completed the square, it gives me a perfect square trinomial. So both of those had a minus sign. The square root of x squared is x. And the square root of 25 over 4 is 5 over 2. You could write that as a decimal. 5 divided by 2 is 2.5. That goes here. Now, I still need the y by itself, so I'm going to go ahead and add this 13.5 to the other side. So y is equal to negative 2 times x minus 2.5 squared plus 13.5. Now I am written in vertex form. Now, since this opens downward, that means I have a maximum. So I have a maximum at, and then you're going to state the y value of your maximum. Now remember, the vertex is always going to be this part, comma, this part. So this is the y value of your vertex. That means that's the high point. So you have a maximum at 13.5. So on number 14, first you're going to move that constant. So I have y minus 7 equals 3x squared minus 9x. Then I'm going to factor out, oh, sorry, that's negative 3. Now I'm going to factor out whatever number is sitting with my x squared. That would be negative 3. So negative 3x squared divided by negative 3 is x squared, and negative 9x divided by negative 3 is positive 3x. Now I want to complete the square. So I know that I'm going to add a number to this side, and I'm going to add a number in this parenthesis. So I take the 3, I'm just going to do it out to the side, and divide it by 2. And then I have to square that. And if you want to do decimals, that's fine. 3 over 2 squared would be 9 over 4. which happens to be 2.25. Now remember, this isn't going to be 2.25. It's 2.25 times negative 3, which happens to be negative 6.75. That's the part where everyone messes up. Make sure that you take that number that you put in this blank times the number that you have on the outside. All right? So I'm going to combine the negative 7 and the negative 6.75, and that gives me a negative 13.75. Then I have my negative 3 times, and then this made a perfect square trinomial. There's a plus in the front. Square root of x squared is x. And then the square root of the 2.25 would have been what I squared, so 3 divided by 2, which is 1.5. And then all I have to do is add the 13.75. So y equals negative 3 times x plus 1.5 squared plus 13.75. So there's my vertex form. Since this opens downward, I will have a maximum at the y value of the vertex. Remember, this was the x value, so this is the y value. So a max at 13.75. So number 15, I'm going to move the 9. So y minus 9 equals 2x squared plus 12x. All right, I need to get that number out from in front of my 2. So I have y minus 9 equals, or out in front of my x squared. I said out in front of my 2. Out in front of my x squared, so I'm going to factor out a 2. 2x squared divided by 2 is x squared, and 12x divided by 2 is 6x. Now I need to complete the square, so I know I will add a number to the left, and I will add a number inside this parenthesis. So I take the number in front of x, that's 6, divided by 2, that's 3, square it, and I get 9. Now remember, this is not 9, this is 9 times 2, so that's 18. So over here I have y plus 9 equals 2 times my perfect square trinomial, plus sign, the square root of x squared is x, the square root of 9 is 3, and then all I have to do is subtract 9. So y equals 2 times x plus 3 squared minus 9. Since this parabola opens up, because your a is positive, you're going to have a maximum at, oh, not a maximum, a minimum. It opens up, so you have a minimum at the y value of your vertex, which is negative 9. All right, number 16. I need to move the 93, so I have y plus 93 equals negative 3x squared plus 36x. I need to get that number out from in front of my x squared, so I factor out a negative 3. Negative 3x squared divided by negative 3 is x squared, and 36x divided by negative 3 is negative 12x. Now I complete the square, so I know I'm going to be adding a number to both sides. I'm going to take that 12, divide it by 2. That gives me 6. 6 squared is 36. Now remember, you're not going to be adding 36 on the left. It's 36 times negative 3. So that's going to give you negative 108. So I have y minus 15 equals negative 3 times, and then my perfect square trinomial, x minus 6 squared, square root of 36, and the square root of x. And then all I have to do is add 15. So y equals negative 3 times x minus 6 squared plus 15. Since your a is negative, this opens down and you have a maximum. So we have a maximum at the y value of your vertex, so a maximum at 15.